When I first saw the images of the human brain neural network published by Shapsenko et al. In the renowned journal Science, I was profoundly moved. This story details how neuroscientists from Google and Harvard University meticulously mapped a tiny fragment of the human brain, unveiling an intricate and highly detailed atlas of its neural network. Their work offers a fascinating glimpse into the extraordinary complexity of the human brain. The journey began with a 45-year-old woman undergoing surgery for epilepsy. During the procedure, a small piece of her cortex, a region crucial for learning, problem-solving, and sensory processing, was removed. This fragment, measuring about 1 cubic millimeter, was carefully preserved and stained with heavy metals to highlight the intricate details of its cells. The sample was then sliced into approximately 5,000 ultra-thin sections, each just 34 nanometers thick. These slices were imaged using electron microscopes at Harvard University, capturing every minute detail of the brain's architecture. The massive task of stitching these images together fell to Jane's team at Google. Utilizing advanced artificial intelligence, they reconstructed the sample in 3D, resulting in a data set of staggering proportions. 1.4 petabytes, containing 57,000 cells and 150 million synapses. Viren Jain, a neuroscientist at Google, described the profound experience of exploring this detailed map, comparing it to a spiritual journey. The ability to zoom in on a single synapse and then out to millions of pixels revealed the true complexity and beauty of the human brain. As the team delved into the 3D model, they made several astonishing discoveries. They found neurons with unusual features, including some that formed up to 50 connections with other neurons, far more than typically observed. Additionally, they identified neurons with tendrils that knotted around themselves, a phenomenon never seen before. Another remarkable find was pairs of neurons that were nearly mirror images of each other, sending their dendrites in opposite directions, creating a kind of symmetry. Despite the detailed map, Jane acknowledged that much of the data remains unchecked for errors introduced during the image stitching process. The team has proofread hundreds of cells, but this represents only a small fraction of the 57,000 cells in the map. Jane expressed hope that the scientific community would assist in proofreading the map and further exploring its data. Looking ahead, the researchers aim to create similar maps from other individuals' brain samples. However, Jane noted that mapping an entire human brain is unlikely to be feasible for several decades. Hongkue Zhang, director of the Allen Institute for Brain Science in Seattle, Washington, praised the study as a tour de force in human cortex data mapping. The vast amount of data generated will enable the scientific community to explore the microcircuitry of the human cortex in greater detail. Understanding these intricate connections could provide insights into treating psychiatric and neurodegenerative diseases. Young-Soo Kim from Pennsylvania State University emphasized the significance of this map in unveiling new rules of neural connections, helping to decipher the inner workings of the human brain. This monumental achievement marks a significant step forward in neuroscience, providing a detailed blueprint that could unlock the mysteries of the human brain and pave the way for new treatments and therapies. Follow me, and I will bring you more updates on scientific and